So evaluating limits analytically. This video is about basic limits, limits of algebraic and trigonometric functions by substitution. Limit of a constant function. So limit of b as x approaches c is just b. So limit of 3 as x approaches 0 would be 3 because 3 is constant. Limit of identity function. Limit of x as x approaches c would be just c. So example 2, limit of x as x approaches 2 would be simply but 2. So you just substitute when the x is 2. So they're identical. So if the x approaches 2, then this also approaches what? 2. Limit of n power of x. Limit of x to the n as x approaches c would be simply c to the n. So you just substitute. Example 3, evaluate the limit. Limit of x cubed as x approaches negative 2. So just substitute x equal to negative 2 in x cubed. So be negative 2 to the third would be negative 8. Limit of a scalar multiple. Given the limits, limit f of x as x approaches is equal to 12. Limit of g of x as x approaches is equal to n. Then for a constant k, limit k times f of x as x approaches c would be k times the limit of f of x as x approaches c. Now use limit of f of x as x approaches c is L, so this becomes k times L. Example 4, given limit f of x as x approaches c is 5, find limit of 6 times f of x as x approaches c. So you start with limit of 6 times f of x as x approaches c would be 6 times the limit of f of x as x approaches c. Now we replace this one. Its value, the value is 5, so it becomes 6 times 5 would be 30. Limit of sum of functions. Given the limits, limit of f of x as x approaches c is L, limit of g of x as x approaches c is m. Then the limit of f of x plus g of x as x approaches c would be the limit of f of x as x approaches c plus the limit of g of x as x approaches c. So this becomes L plus m. Example 5. Given the limits, limit of f of x as x approaches c is 5, limit of g of x as x approaches c is 8. Find the limit of f of x plus g of x as x approaches c. So let's have a limit of x approaches c, f of x plus g of x. This will become limit of f of x as x approaches c plus limit of g of x as x approaches c. Now substitute the limit of f of x is 5, the limit of g of x is 8, so 5 plus 8 would be 13. Limit of difference of function. Again, the limit of f of x as x approaches L, limit of g of x as x approaches is m, then the limit of f of x minus g of x as x approaches c would be the limit of f of x as x approaches c minus the limit of g of x as x approaches c. So limit of f of x as x approaches L, limit of g of x approaches m, so it becomes L minus m. Example 6. Given the limits, limit of f of x equal to 5, limit of g of x as x approaches 8. Find the limit of f of x minus g of x as x approaches c. Limit of f of x minus g of x approaches c, we can break it down into limit of f of x minus the limit of g of x. We replace the limit of f of x with 5 and replace this with 8. So it becomes 5 minus 8 will be equal to minus 3. Limit of quotient of functions. So given the limits, limit of f of x as x approaches L, limit of g of x as x approaches is m, then the limit of f of x over g of x as x approaches c will be equal to limit of f of x as x approaches c over limit of g of x as x approaches c. Now the limit of f of x as x approaches L, limit of g of x is m, so the result is L over m. Example 7, given the limits, limit of f of x as x approaches is 5, limit of g of x as x approaches is 8. Find the limit of f of x over g of x as x approaches c. Okay, solution. Limit of f of x over g of x as x approaches c would be limit of f of x as x approaches c over limit of g of x as x approaches c. So we substitute the limit of f of x is 5, then limit of g of x is 8. So the result is 5 over 8. Limit of a polynomial function. If p of x is a polynomial function and c is any real number, then the limit of p of x as x approaches c would be simply p of c, or polynomial evaluated at c. That is, to find the limit of polynomial p of x, just substitute x equal to c in the polynomial p of x to get p of c. Example 8. Find the limit of polynomial. So limit of x cubed minus 5x minus 1 as x approaches 2. So we just substitute 2 in the polynomial. So we got 2 to the third minus 5 times 2 minus 1. 2 to the third is 8, 5 times 2 is 10, and minus 1. So 8 minus 10 is negative 2, negative 10, negative 2 subtract 1 be negative 3. Limit of a rational function. If p of x over q of x is a rational function, p of x and q of x are polynomials, then limit of p of x over q of x as x approaches c would be polynomial p evaluated at c, polynomial q evaluated at c, provided the q of c is not 0. That is, the limit of rational function p of x over q of x can be found by substituting x equal to c to get p of c over q of c. Find the limit of rational function. The limit of x plus 1 over x squared plus x plus 2. So you just substitute x equal to 2 in the rational function, top and bottom. So it becomes 2 plus 1 over 2 squared plus 2 plus 2. 2 plus 1 is 3, 2 squared is 4, plus 2, 6 plus 2. So the result is 3/8. Example 10. Find the limit of rational function. Limit of 2x plus 3 over x squared minus 3x plus 2 as x approaches 2. So substitute x equal to 2. So it'll be 2 times 2 plus 3, 2 squared minus 3 times 2 plus 2. So 2 times 2 is 4, 4, 6. So 4 plus 3 is 7, 4 minus 6 is negative 2 plus 2, 0. 7 over 0. Division by 0 is not possible or is infinity, so the answer would be D and E. Limit of radical function for odd n, like 3, 5, so on, and for all c, limit of the nth root of x would be simply the nth root of c. You replace the x with a c. For n equals to 2 and 4 and for constant c greater than 0, so if n is even, then c has to be positive. The limit of nth root of x as x approaches c would be the nth root of c. Example 11. Find the limit of radical function. Limit of square root of x squared plus 9, x approaches 0. So we substitute 0, and 0 squared is 0, plus 9 is 9. So square root of 9 is 3. So the answer here is 3. Limit of a composite function. If f and g are functions such that limit of g of x as x approaches L, then the limit of f of g of x as x approaches c would be f of limit of g of x as x approaches c. So then we write f and then replace this with L. So the answer is function evaluated L. L is not multiplication. So you have to evaluate f function at this number L. Similarly, limit of fx as x approaches c is m, then limit of g of fx as x approaches c would be g of limit of f of x as x approaches c would be f evaluated m, because that's the m is the limit value of this one. Example 12. Limit of a composite function. So given f of x equal to 5 minus x, g of x is equal to x cubed, then the limit of f of x as x approaches 1 will be equals to limit of 5 minus x as x approaches 1. You substitute x equal to 1, so this becomes 5 minus 1, which is 4. Limit of g of x as x approaches 4, I'll replace g of x by the given x cube. So it becomes limit of x cube as x approaches 4, substitute x equal to 4 and simplify. Becomes 4 to the cube equal to 64. Example 13, limit of a composite function. So limit of g of f of x as x approaches 1. So this you can rewrite g of limit of f of x as x approaches 1. And from part A, we found limit of f of x as x approaches 1 is 4. So we replace this 4. So now we have g of 4. You have to evaluate g of 4. But g of x is given x cubed, so we're going to substitute 4 here and here. So this will become 4 to the third, which is 64. Limit of trigonometric function. Let c be any real number and in the domain of the given trigonometric function. Then the limit of sine of x at x equal to c as x approaches c will be sine of c. Limit of cosine of x as x approaches c would be cosine of c. Limit of tangent of x as x approaches c would be tangent c. Limit of cosecant x as x approaches c would be cosecant of c. Limit of secant x as x approaches c would be secant of c. The limit of cotangent of x as x approaches c would be cotangent of x. So basically, you just substitute whatever c is in the arguments of these trigonometric functions. Example 14, finding a limit of trigonometric function. So limit of cosecant pi x over 12 as x approaches 2. So we substitute x equal to 2, so it becomes cosecant pi times 2 over 12, simplify cosecant pi over 6. And cosecant is using quotient identity, we can rewrite 1 over sine pi over 6. Now from unit circle, sine pi over 6 1/2. So it will be 1 times 2 over 1, and the answer is 2.